Welcome to the workshop. I'm sitting here with our Shark CNC, our take at a professional CNC router for milling wood and plastic and aluminum. I will take you on a tour how it's built, and I'll also show you a bigger model that I have sitting over here. So hang in. So here it is from a front view, and if I go closer you can see some of the details. First of all, the main body is built with heavy duty 80/80 profiles. You can see the end here, which is the 80/80, as well as the legs that are also 80/80, and they are on pivot foots, and they also have some stiffeners on the side here, on this side, as well as this side. That goes for all the four legs. The y-axis is also a 80/80 profile, and the x-axis, it's a little hard to see the profile, but it is here. It's a 80/160 heavy-duty profile. This allows the machine to be quite wide. As you can see, the three axes, they are covered with bellows. So we have now we have the machine in the front, so this is pretty compressed, whereas the other end is open. And this is to cover the linear guide and the rack and pinion system from dust and debris. On the x-axis, the bellows is more like a curtain, so here we have the compressed side, and on the other side it's open because we have it all the way to the left. The z-axis is open, so you can get some chips collection here. And you have a ball screw drive on the z-axis here, and you see the z-axis motor up here. This is equipped with a integrated closed loop stepper, and that means that this is the driver, and you have an encoder sitting up here, and then the stepper motor is here. On the two other axes we have chosen to put servos on. Here we have, it's a 400 watt servo, again closed loop with the integrated driver sitting here and the encoder up here. To get even more power, the motor is connected via planetary gear down to the pinion, which is inside this case here. So this is either 1-7 or 1-10 gear, and it's the same. You will see it on the other side there. So we have two Y motors as usual. If we go around the machine here, we can see the X motor sitting here, and again it's a 400 watt integrated servo connected with a gearbox, and in this case we have chosen a 90-degree gearbox in order to get the motor a little more out of the way, otherwise it would be sticking out here, which is a little annoying. I can show you how the drive looks if we open here. So here we have the drive system. So you have the two 20 millimeter linear guides, and this is a helical rack, 1.25 module rack. Out here there is an end stop, physical end stop, but of course we use the soft limits as well. In order to keep the curtain connected, we have some powerful magnets mounted here, and it's riding on some aluminum rails. You can see it here, and you can see it up here. So it has some notches here that makes it ride nicely here. This can of course be lubricated if you like. I haven't done it. Like that. So now it's connected. The bottom and the top here is a PVC block that I have milled and put in holes, and on that the aluminum bracket that holds the curtain is mounted. Can also open here. Essentially the picture is the same. The motors, both on X and Y, is mounted on a piece of aluminum here, and you can see there's a spring down here, and some will probably recognize this pattern as a MGN pattern for a linear block, and that is because we have made it so that it can be lifted out of the rack. So in case of some kind of collision, it will pop out and just grind on the teeth rather than completely block the whole motion and risking to burn the motor. And secondly, if these two are not 100% parallel, then this way will allow it to just move, you know, a bit up and down to compensate for whatever loss of parallel between these two. So in essence it has two versions. I have seen builds where they kind of pivot the motor on something, but I think this is a far more elegant way to design it. The XC gantry system is made out of 10mm aluminum plates that have been milled into shapes that we have designed, and you can see that the C motor is sitting here on a cast iron bracket that connects it to the ball screw. Some 3D printed curtains here protect the rails from the side, and you can see the C end switch sitting here. Again, this is one of the Y motors, and as mentioned, it's also positioned on some small rails so it can move in and out, and the tension is determined by this spring right here. Right now I have a MDF spoil board mounted on the machine, and the mounting is done on these 40-80 profiles that goes across the machine. Yeah, the last thing I can focus on, I think, is that we have underneath here we have some 3D printed covers, and then it ends with a piece of acrylic, and you can see that there's a little piece sticking out here with holes in. It's not being used on this side, however it's used on the other side. It's to connect the cable chain, so the cable chain can be on either side, whichever you feel is more convenient for your setup. The same goes with the direction, so the cable chain can in principle go this way and then around, or it could also be mounted so it goes the other way. It depends on where it's nice to have the wires coming out. I'll just run around to the other side. You can see it. It's sitting here. So there's a bracket here, and then it's resting on something here that allows it to go back, but you could easily just turn it the other way around if that was what you wanted. The spindle that we mount on this machine is one of these 2.2 kilowatt 80mm spindles. They come with a heavy duty aluminum bracket, from the factory, these holes are not drilled, so that is something one needs to do before mounting it. And then we have designed a dust shoe. It is this main house here, and then two brackets that are connecting to the spindle cylinder. They hold the tube that goes out with the hose there. And it's actually made so that if we unscrew this one, this whole house can be removed. If you for some reason don't really want the dust shoe there, you can unscrew this and then remove the whole thing away. And then these things will still be there, and you don't need to remove the hose. The hose is kept up with a glass fiber rod inside. You can see it takes kind of gives it a good curve. And then I have mounted some kind of a roll up there with spring, so it can move out like this. And then there's also glass fiber rods in the other end here, and then it connects to the end profile here, also with a 3D print, and then it comes out here, and this one will be the one that connects to the vacuum. As a last part of the mechanical setup, I have added a piece of 80-160 profile between this front and this one, so it can support the vise here. So it's sitting on that, and I have it's positioned so that if you have something that sticks out here, it will clear the front, and also in the if it goes the other way, it can clear the back, which is very convenient. And then if I don't use it, I can just unscrew it and then take the lid, which is this piece of MDF, and just put it on to the hole here, and then I have a all MDF spoil board, just with a little gap here of whatever 4 millimeters or so. For the Shark CNC, we have chosen to use Acorn controller. It's a really versatile controller that has lots of inputs, outputs, and so on and so forth. It's a very professionally designed interface, and what is really nice is that it is a touch screen, so you can actually just touch here to make it move. So all of that is, so you really don't necessarily need the keyboard and mouse a lot to operate the machine. The Acorn also supports a MPG. It's this one. So you can jog the machine. And I find it super handy to have that one as well. So to control the machine, I'm using a Nuke PC, which is sitting here behind. For this machine I made a tray that can be stowed away for keyboard and mouse, and also something I made extra here. I made this stand that allows the screen to be positioned in a nice way in front of the machine. Over here I have an e-stop and also a bracket that I can put the MPG on, and on this side here I have the two wrenches that are being used for clamping and unclamping tools in the spindle. On the side of the house, the dust shoe has this opening, and it's meant for the wrench coming in here, so you can do the unclamping, and the second one goes beneath here, but when you use it, it's possible to close the opening with a little lid like this. And then finally we have the bristles here. They are magnetic, they just go on here. Like that, and the second one like that. Yeah, let's take a look into the control cabinet. Here we have it, and up here we have the VFD, and we have two 450 watt Meanwell PSUs sitting here, and a second PSU here. It's a dual voltage 5 and 24 volt PSU for the Acorn, which is sitting here. And the Acorn is using an Ethernet connection to connect to the computer. And then we have all the inputs and outputs, and then we have a relay station here with 8 relays that can be used for various things. And all input outputs, they are connected via this DIN rail here. So we have pre-wired everything on the one side, and then it's just a matter of connecting motors and switches and what have you to those inputs and outputs right there. So let's turn from the smaller machine to the bigger one. It's over here. It's a full sheet machine that has extra space behind to add a ATC or something if you want to do that, or other things. So it has ample travel on the y-axis. But apart from that, it is the exact same construction, same dimensions and everything, except that this is longer. And here we have the dust collector connected. On these machines I have used the relays to connect some extra items that are useful during operation. For example, I have connected the shop vac to one of the relays so I can power it up from the screen. And also the mist, if we look down here, I have added some relays down there that can open and close the air. So if I hit the mist, you can see then I have a mist of air mixed with alcohol that I can use for cutting aluminum. And then finally I have made some positioning cylinders to make it easy to put up a sheet of plywood. If I activate it, you can see that there's one here and another two further down here. I can see if I can do both, camera and as these cylinders, they have pressure on both sides, so they have pressure pushing them up, but they also have pressure pushing them down. In principle, you could use them as a hold down if you mount something into the thread here, and then you push something down on this here. You could actually use them as a kind of a workpiece hold down also. I haven't tried that yet, but at least it's a thought. The machine is available as a kit for self-assembly on makersupplies.dk, and I hope you liked what you saw. At least I'm very happy about using it.